All right, this is Pre-Algebra Unit 2, Equations and Inequalities. Unit 2, Lesson 2, Solving Multi-Step Equations. This is the benchmark MA.8.AR, so Algebraic Reasoning, point 2.1. And we are solving multi-step linear equations with one variable with rational number coefficients. So rational number is just your fraction or decimal. Nothing too fancy there. All right, this is what your notes should look like. So we'll have some vocabulary terms, some steps, general steps that we can follow, some examples, some more examples I'll go over, and then you can try these on your own. So let's get started. First, let's review what it means to solve an equation. Okay, so we're going to isolate the variable to get the variable by itself. And remember, when we're solving an equation, whatever you do to one side of an equation or the equal sign, you must do to the other side of the equal sign or the equation. The steps that we're going to follow is first to simplify. And what it means to simplify is either we are going to combine like terms. So if we have an x on the same side of an equal sign, then we're going to combine our like terms, or we have to distribute. So I'm going to write or provide this example for you as I describe these steps. And this example should be included in your notes for my students. And here, what does it mean to combine like terms? Well, we're going to box our variables. So we're going to put a box around the 3x, and we're going to put a box around this negative 2x. And it's important to know that this negative sign is attached to this coefficient 2, which is also attached to the x. So we're going to put a box around the whole thing. So 3x minus 2x, if we're going to combine those like terms because they are on the same side of the equal sign, we get x. Then we're going to circle our constants. And here we have a constant, negative 4. Again, I'm going to include the sign in my circling. And I have a positive 6. So I will include that 6 or that positive sign with my 6 so that I know and remember that that is a positive 6. When I combine these like terms, negative 4 plus 6 is a positive 2. So now I have simplified this left side of the equation, this left side of the equal sign. So that all became, this right here all became x plus 2. Now I'm going to worry about simplifying the right side of this equation, because I have a 3, which is a coefficient, and that's being multiplied times x minus 2. So if I have something that's outside of the parentheses, I have to distribute that coefficient inside the parentheses. So when I distribute this 3, I'm really multiplying 3 times x. So I'm going to get 3x. And 3 times negative 2, because remember that sign is attached. This symbol right here, or operation, is attached to that 2. So 3 times negative 2 gives me negative 6. So this right here is a simplified version of this long equation. Now we're going to work towards actually solving it. So if there are variables on both sides, like there are here, we need to move them to the same side. So here I have an x and I have a 3x. So I like to move things wherever I have more of them. So 3x's is more than 1x. So to move this variable, I can add or subtract it, because we can add or subtract our variables or our constants. So we're going to subtract x from both sides. So I'm left with a positive 2 is equal to 2x minus 6, because 3 minus 1x, because there's an implied 1 there, becomes 2. Then I'm going to add this constant, because it's negative 6 over here. I'm going to add 6 to both sides to bring it over here. And the reason why I added 6 is because I want this constant to become 0. So negative 6 plus 6 will give me 0. So now I'm left with 8, because 6 plus 2 is 8, is equal to 2x. So my last step is going to be to multiply or divide by the coefficient. And our coefficient at this stage is the 2. So I have to divide both sides by 2 to get rid of this coefficient. And so my final answer is x is equal to 4. Okay, we're going to move through a few more examples here. So we have 3 times x minus 5. is equal to 6. So we have two options here, actually. Our first option would be to divide by the coefficient, which is 3, so we don't have to distribute it. So if we decided to divide by this coefficient 3, we're going to divide by 3 on both sides, and then we end up with x minus 5 is equal to 2, because 6 divided by 3 is 2. Then my next step would be to move this constant away from the variable. So this is a constant, and the constant here is negative 5. So to make that 0, I have to add 5 to both sides. So x is equal to 7. Now, if I wanted to do it the other way, my second option, and sometimes what most students are taught in 6th grade, is that this 3 actually has to be distributed to the parentheses. So we would distribute 3 times x and get 3x, distribute the 3 times negative 5 and get negative 15, and that is equal to 6. Now I'm going to, once I distribute or simplify and get rid of the coefficient, then I would box my variables and circle my constants. So I only have variables on the left, so I'm going to move this constant to the right by adding 15 to both sides. Because this was negative 15, I wanted to make it 0, so I added 15 to both sides. So now I'm left with 3x is equal to 21. And my last and final step here would be to divide by 3. Because this 3 is a coefficient, I can only divide by 3 to get rid of it. I can't subtract 3 because that 3 is being multiplied to the x. So the inverse operation would be divide by 3. So no matter which way you solved it, either way I got the same answer. This only took me 2 steps, whereas this took me 3 steps. There will be a time and a place to use either method. All right, in question number 2, I don't have to distribute anything. There is no coefficients or parentheses. So I can start right away by boxing my variables and circling my constants. I put the line here from my equal sign to indicate that there is a wall, that there is a separation between this side of the equal sign and this side, because I cannot combine terms across the equal sign. So first I'm going to combine like terms. 4x plus 2x is 6x. Then I still have the negative 5 is equal to 25. Now I need to move my constant negative 5 over here. So in order to do that, I'm going to add 5 to both sides so that this becomes 0 and 25 will then become 30. So first I combined like terms. Second, I added or subtracted the constants to the other side. And my last step is going to be to divide by this coefficient 6. I divide both sides by 6 and x is equal to 5. Question number 3, I have 6x minus 4 equals 2x plus 16. Again, here's that line indicating there is a separation between these terms. So I cannot combine like terms across the equal sign. So I must use addition or subtraction to move the variables to one side. So I have 6x and I have 2x. Because this number is greater, I'm going to move this 2x over here by subtracting 2x, because this is a positive 2x. If I subtract 2x from both sides, the 2x will be gone from this side. So then I'm left with 4x minus 4 is equal to 16. So now I need to add or subtract the constants to the other side. So I'm going to add 4 to both sides, and 4x is equal to 20. So my last step here would be to divide by the coefficient. So 4 divided by 4 would be 1. So I'm just left with the variable. And 20 divided by 4 is 5. So x is equal to 5. Here we have question number 4, and this is a coefficient. Now, I could divide by the coefficient first. However, Most students do not know how to divide by a fraction properly. So my recommendation would be to distribute the coefficient to the parentheses first. So 1/2 multiplied times 8x is going to give me 4x, and 1/2 multiplied times 4 is going to give me 2. Then I still have the 2x plus 10. So now once I've distributed or gotten rid of the coefficient in the parentheses, that's when I can box my variables and circle my constants. I have 4x and I have 2x, so I'm going to move this 2x over here to the left by adding or subtracting the variable 2x. So I'm going to subtract 2x from both sides, and I'm left with 2x plus 2 is equal to 10. So now I have to add or subtract the constants to the other side. 2x is equal to 8. Then my last step would be to divide by the coefficient. So I'm going to divide both sides by 2, and x is equal to 4. Hopefully you are starting to get the hang of it. The purpose of these color codings are so that you can keep track of what you're doing, and when you look back at your notes, you have steps that you followed. Okay, here's a few more examples. We didn't have to distribute, so we can start right away by boxing and circling our variables and constants. We're going to add or subtract the variables to one side. So I only have a constant here on the left. So yes, I have more variables here on the left, but because I don't have a constant on the right, I can just go ahead and move this variable over here. So if I have a positive 6x, I would subtract 6x from both sides so that I have constants on one side and variables on the other. So now I have negative 8 is equal to negative 2x. Then I have this coefficient, negative 2. So I'm going to divide by the coefficient. I can't add. I have to divide by the coefficient so that it becomes 1. And negative 8 divided by negative 2 is going to give me 4. So my answer here would be 4 is equal to x, or you could rewrite it as x is equal to 4. All right, question number 2. The first thing I need to do is distribute. You cannot divide this coefficient away, or I wouldn't recommend it, because if you did, you would end up having a decimal over here on the left, and most students prefer not to work with decimals. So 2 times 3x is equal to 6x. 2 times 6 is equal to 12. So once I've distributed and gotten rid of that coefficient, now I can box and circle my variables. And I have more variables on the left, so I'm going to subtract my 6x from both sides. 7x minus 6x leaves me with 1x. Then I still have the negative 4, or minus 4 is equal to 12. Now I'm going to add or subtract my constants to the other side. So to make negative 4 0, I'm going to add 4 to both sides. So if I add 4 here, this cancels out and becomes 0, and 12 plus 4 is equal to 16. So x is equal to 16. It only took really 3 steps to solve this equation, because once I distributed and subtracted, I was only left with 1x. I did not have to divide in my last step. All right, question 3. I have a variable, another variable, a constant, my equal sign, so I draw my line, and 47. So I'm going to combine my like terms that are on the same side. 9x and minus 4x gives me 5x. Then I have this positive 17 and 47 is equal to 47. So now I'm going to move the constant to the other side by subtracting 17 on both sides. So then I'm left with 5x is equal to 30. My last step would then be to divide by the coefficient. In this case, that would be 5. So I'm going to divide both sides by 5, and x is equal to 6. Last question, I have a denominator. I have 2x plus 8 is being divided by 6, and that's equal to 4. Well, When that happens, what I have to do to get rid of that denominator is multiply the whole equation by 6. When I multiply by 6, that cancels out. So I'm left with 2x plus 8 is equal to 24, because 4 times 6 is 24. Then I can box my variables and circle my constants. So I'm going to move my constant of a positive 8 over